All right, let's fill out our learning card on building a normal curve. So we have a normal curve, which is a bell-shaped curve right here, and we want to build it. How do we put it together? What should we be recognizing when we look at this normal curve? Well, one thing that we should always pay attention to is we should pay attention to the context of the problem. So we're looking at ages of people here, because this down here at the bottom says what percent of the people fall between 73 and 79 years old. So we'll get to this a little bit later on, but this gives us a little bit of context. We're looking at the ages of people. So in order to start putting this together, we want to start with the mean. We always want to start with the mean. We also want to use the standard deviation to determine the sections here. These sections are going to be broken down into pieces. This curve is going to be broken down into sections, and we want to use the mean and standard deviation to break them down. One of the other things that's important for us is to know the symbols for these. So the mean here is given by the symbol mu, and standard deviation is given by the symbol sigma. Looks like that. So when you put this together, you should know what the mean and the standard deviation are. For us, the mean mu is going to be 77 years of age, and the standard deviation is going to be 2. If we don't know what the values of the standard deviation and the mean are, if we don't know what those are right here and right here, then we can't build this curve. Okay, we can't build this normal curve. So now that we know those, we can start to put things together. Now there's something else that we need to talk about before we actually start to build it, and that is don't forget to add percents using the empirical rule. Okay, now the empirical rule can also be called the 68, 95, 99.7 rule. And the reason why it's 68, 95, 99.7 rule is because those numbers, 68, 95, and 99.7, are going to give us the percentage of the area underneath of our curve. It's very important. The percentage of the area underneath the curve is given by 68, 95, 99.7 rule. So let's start to put this together, and it'll make a little bit more sense. All right, so when we have a normal curve, it's bell-shaped like this, the mean is right in the middle. So I'm putting mu, the mean, right in the middle, and it is 77. So now I'm going to start to use my standard deviation to build the rest of this curve. If I were to go out one standard deviation above the mean and one standard deviation below the mean, it would take me to about this location or this location. So here you can see if I add one standard deviation, it's going to take me from 77 to 79. Why from 77 to 79? Well, the standard deviation is 2, so one standard deviation above the mean would be 77 plus 2, which is 79. Now over on this side, if I subtract or take away one standard deviation or one standard deviation below the mean, that would be 77 minus 2, which is 75. So at this point in time, I've gone one standard deviation above and one standard deviation below the mean. Well, what does that tell me? What else can that tell me if I go one standard deviation above or one standard deviation below? Well, one thing that it can tell me is this. If I were to put a vertical line there and another vertical line here, I would create a section that is a piece of the normal curve. And if I were to highlight that section, let's go to a highlighter here. If I highlight this section right here, this entire green section that's being highlighted would represent 68% of all the data that is underneath of this curve. So all of this in green is 68% of everything that's under the curve. That is proportionally correct. If 100% of my data is underneath of this curve, then 68% of it is going to fall between one standard deviation below and one standard deviation above the mean. If I broke it down into the two halves, That means 34% would be between the mean and 1 standard deviation below the mean. 34% would be between the mean and 1 standard deviation above the mean. But between those two, 1 standard deviation below and 1 standard deviation above the mean, we get 68% of our data. Well, what if I go 2 standard deviations in both directions or 3 standard deviations in both directions? Let's take a look at that. All right, let's take a look at 2 standard deviations in both directions. So if I go 2 standard deviations, I'm going to go from 77 down to 73 because minus 2, that's our standard deviation. And if I go 2 standard deviations above, 77 plus 2 takes me to 81. Now, what does this tell me? Well, the area underneath of the curve from 73 to 81, or in other words, 2 standard deviations below the mean to 2 standard deviations above the mean, is going to be 95% of all of the data. So now that I add to this picture, everything that is highlighted in yellow and green together is 95% of all of the data underneath of the curve. Now, if I wanted to break it down a little bit further and just find the area of this yellow section right here, I could use a little bit of algebra and take 34% or take 95% and divide it in half, and then take whatever half of 95% is, subtract away 34, and that would give me the area that goes right here in just this section of yellow or just this section of yellow, which, by the way, would be 13.5% in each one of those little sections. I don't know that it's necessary to put that in there, but being able to do that algebra in your head or on a piece of paper is pretty important. What about 3 standard deviations in both directions? Well, if I go 3 standard deviations above, that's going to be 77 plus 2 plus 2 plus 2, which takes me to 83. Or 3 standard deviations below, that's 77 minus 2 minus 2 minus 2, which is 71. And the area under the curve from 71 to 83 is about 99.7% of all of the data for this normal curve. So this right here is called the empirical rule. That's why these percentages give it the name the 68, 95, 99.7 rule. Now, I really want you to take note of this. The only time you should really use the empirical rule and these values of 68, 95, 99.7 is if you are asked to use the empirical rule. There's going to be another method that we use to find the area under a curve, and that's using, we can use our calculator or we can use a table to try to find more specific areas under the curve. These are just estimates. This is an important rule to keep in mind, but these are just estimates. So the only time you should use the empirical rule and these specific values is if you are specifically asked to use it, or if you specifically are looking at 1, 2, or 3 standard deviations above or below a mean. Let's go ahead and answer this last question. It says, what percent of the people fall between 73 and 79 years old? Another way to write this is with probability. This is the same as saying the probability that X, and X is our ages, X represents our ages, X is between 73 and 79. So this probability notation is another notation that we're going to be using a lot as we continue to use normal curves. Well, in order to find this, I need to find the area from 73 to 79, the area under the curve from 73 right here to 79 is the probability or the percentage of people who fall between those two ages. So if I do this calculation, in green here, I have 68% of my data. And then earlier we counted this little section of yellow, which was 13.5%. So if I add 68% to 13.5%, then I end up getting 81.5%. So again, I want to reiterate that I was able to use the empirical rule and this model that I've created because I was asked to find the area between 73 and 79, which land exactly on 2 standard deviations below the mean and exactly 1 standard deviation above the mean. If you do not have values that land exactly on 1, 2, or 3 standard deviations above or below the mean, then you should not be using the empirical rule. You want to use a different method, whether it's your normal CDF on your calculator or using a table, but you want to use z-scores. That's that's a different topic that relates to normal curves. This is just how to put one together and what are the basics behind a normal curve. So hopefully this helps you understand normal curves a little bit better, and hopefully you have fun in your stats class.